Let's now talk about another measure of location, which is the median. So the median is literally the middle value, i.e. is the value that divides the data set into two halves. A lower half and an upper half. For a data set with an odd number of observations, so for odd number of observations, the median is literally the middle value. For a data set with an even number of observations, the median is the average of the two middle values. Okay. So now, how do you find the median? To find the median, you want to follow the following two steps. First off, you want to arrange your data from smallest to largest. In other words, you want to arrange your data in ascending order. Step 2, you want to remove the outermost values one by one. So remove the outermost values one by one until there's one value or there are two values left in the middle. If there is one value in the middle, then the median is equal to that value. And then if there are two values in the middle, right, the median is going to be the average of those two values. Now this looks kind of abstract, right? So let's look at some examples with specific numbers. Suppose I have the following data set. Suppose my data set contains 3, 3, 6, 6, 7, 9, 10, 12, and 12. Let's go ahead and find the mean and the median of this data set. Now, first off, you should note that the numbers have been arranged in ascending order, so that's good for us, right? That takes care of the first step in finding the median. Let's calculate the mean. So to find the mean, you want to add up all these numbers and then divide by the number of items, right? In other words, you want to take 3 plus 3 plus 6 plus 6 plus 7 plus 9 plus 10 plus 12 plus 12 divided by, here we have a total of 9 observations, so you divide it by 9, and that gives you a mean of 7.56. Okay, so that's straightforward. Now let's go ahead and find the median. Let me rewrite the numbers down here. So I have 3, 3, 6, 6, 7, 9, 10, 12, and 12. What I want to do is I want to remove the outermost values until I end up with 1 or 2 values in the middle. So let me first remove 3 and 12. And then I want to remove 3 and 12 again. Then 6 and 10, 6 and 9. So now I end up with 1 value in the middle, right? And that value is going to be equal to my median. So the median in this case is going to be 7. Now you may be wondering at this point why we even care about the median. And that's a perfectly good question to ask. So why care about the median? The answer to that question is that we care about the median because the median is a better measure of location. If there are extreme data points in the dataset. Okay, so let's look at a quick example. Suppose I have income at a small firm. Let's say I have salary in thousands of dollars, and then I have the number of employees earning those salaries. Let's say I have 4 people earning $50,000, 2 people earning $60,000, 2 people earning $70,000, 1 person earning $80,000, and 1 person, probably the CEO, earning $100,000. Let's go ahead and find the mean and the median of this data set. The first thing I want to do is let's arrange these numbers in ascending order because I'm gonna have to do it anyway, right? So if you arrange the salaries in ascending order, you're gonna have 50 appearing 4 times because you have 4 people earning $50,000. And then I have 2 people earning $60,000, so 60 appears twice, 70 is gonna appear twice, 80 appears 1 time, and then 100 appears 1 time, right? Now if you do the math, that gives you a mean of 64,000. I'm not going to show you the math, but at this point you should be able to calculate the mean on your own. Let's look at the median. To find the median, I want to remove the outermost values one by one until I end up with 1 or 2 values in the middle. So I'm going to remove 50, I remove 100, 50, 80, 50, 70, 50, 70. So I end up with 2 60s in the middle. And so the median is going to be the average of those 2 numbers, which is $60,000. Now, suppose for a second, right? Let's say the CEO decides to pay himself or herself $1 million instead. Right? So, suppose 100 becomes 1,000. Right? Let's calculate our mean and our median in this new data set. Now when 100 becomes 1,000, that 1,000 value is going to be an extreme data point. And the reason it is extreme is because it's so far from the rest of the values in our data set. So let's arrange the new data set from smallest to largest. So I have 50 appearing 4 times, then I have 60 appearing twice, 70 appearing twice, then 80, and all of a sudden I have 1,000. Now, if you work out the math, the mean is going to be 154. Okay, so all of a sudden, when we have an extreme value in our data set, the mean goes from being equal to 64 to being equal to 154. That's an increase of 90. So the mean is very easily influenced by extreme data points. But let's look at the median. So the median, we find the median by, again, removing the outermost values one by one until you end up with 1 or 2 values in the middle, right? So if I remove 50, I remove 1,000, 50, 80, 50, 70, 50, 70. So I end up with 60 and 60 in the middle. And so the median is going to be the average of those 2 numbers, which is 60, which is unchanged from before. So when you have a data set with extreme data points, the median turns out to be a better measure of location than the mean, because the mean is very easily influenced by those extreme data points. So in this video, we talked about the median, right? We talked about how to find the median, and then we did this particular example where I showed you that when you have extreme data points in the data set, the median is a better measure of location than the mean, because the mean can be easily changed by those data points.